It should come as no surprise that in order to be successful with what we're doing in this unit, we have to have a good grasp of our unit circles. So what you guys see right here is just a blank unit circle. And what I'd like for you to do is if you have a blank unit circle someplace, whether it's in your packet or wherever, see if you can fill out your unit circle just kind of as a refresher. So for both degrees, radians, and then also your points. So what I'm going to have you guys look at right now is this unit circle. Go ahead and take a second, check your answers. Don't worry about the triangle on the side. I'm going to be using that here in just 1 second to kind of make a point on something. So right now, just double check your angles, double check your radians, double check your points. Make sure that you guys are good with this. So it's important that we have a solid grasp of our unit circle in order to be successful with what we're doing today. So as you guys look at 4.7, we are doing the inverse trig functions. Now you guys have seen this in the previous class, probably geometry to be honest, and this is what I'm going to use that triangle for. So if we look at the triangle, you guys have seen in the past, if you have something like this, that you can use trig to find your missing angle. And what you would do for this is you would go ahead and label your opposite and hypotenuse, which I've already done. And you would set up that the sine of x equals the opposite over the hypotenuse. And then to type that in your calculator, you would have to do the inverse sine of 10 over 15 to get that angle measure. What you just did is an inverse trig function. So you are actually figuring out what angle gives you that ratio of 10 over 15. Now, today what we're looking at is exactly the same concept. We are also just throwing in that this has another name called arcsine. So if you look here, that's going to be the same thing. That is an inverse function. Now, one of the things that will trip people up is that what we're looking at is limited in a certain interval. So if we think about inverse functions, if we think about connecting it to your original, so for example, if you're looking at arcsine or the inverse sine function, if we connect it to our original, we have a graph that looks something like this. So it crosses at the x-axis, it does one of these, and then it would go on forever this way. Now, that function as a whole is going to be, the inverse function as a whole is not going to be a function because it fails that vertical line or that horizontal line test. Okay, so remember, if the inverse function is going to be a function, the original has to pass a horizontal line test, which we see that it fails. But if we take a look and we cut what we're looking at a little bit here and here to just focus on that window that I just outlined, now this part will pass that horizontal line test. So if you look at your information up here, this is why our interval is limited to negative pi over 2 to positive pi over 2, because if we look at the window that I just sketched, that's exactly where your minimum and maximum are here. And here is negative pi over 2 and positive pi over 2. Now, if we think in terms of our unit circle, negative pi over 2 and positive pi over 2 is going to be going from here to here. So that's going to be in quadrant 1 and 4. So what we would then do is, again, we have to have a solid grasp of our unit circle. Remember that sine is connected to our y values. So what we would do is look at our unit circle in those two quadrants and figure out, for example, number 1, let me go back, when your y value is 1/2. So we're going to look for that. So we look in those two quadrants, our y value is 1/2 at that point right there. And so the radians that corresponds with that is pi over 6. And that is our answer. And you're done. Okay, if you look at number 2, it says the inverse sine value of pi over 2. Well, if you think about this, if you look at your y values are never pi over 2. The maximum y value that it will be is 1. The minimum y value that it would be is negative 1. Neither of which get you to pi over 2. Pi over 2 would simplify to be over 1 because 3.14 divided by 2 is going to be greater than 1. So in this case, this actually does not exist. It does not exist, okay? And another way to think of this is in our original sine function, in this little window that I just cut out, your domain is going to be negative pi over 2 to positive pi over 2, and your range went from negative 1 to positive 1. It bounced back and forth. And remember, if it's an inverse function, that domain and range is going to flip. So if we look at our sine, or our arcsine or inverse sine, our domain of this one is going to be the original range, which is negative 1 to positive 1. And our range is going to be our original domain, which is negative pi over 2, positive pi over 2. Okay, so if you look at this, this is not in the domain of negative 1 to positive 1. All right. Now, if we look at number 3, inverse sine and sine, those are just going to cancel each other out. So you're going to be left with pi over 9. The only other thing to check for is that pi over 9 is in that interval. And I know that you don't see it on your unit circle, but pi over 9 would be right about in here someplace, which it is going to be in quadrant 1 or quadrant 4. This one, the number 4, if we were to kind of cross these off because they cancel each other out, 5 pi over 6 actually will fall, will be over here at 5 pi over 6. That's not in quadrant 1 or 4. So we would have to take this all the way over here to this one because it has the same y value of 1/2. And so therefore, my value for this one is going to be pi over 6. Okay, so that's kind of the sign. Again, you are looking for your y values that correlate, and then you're getting your radians that produce that y value. Now, if we switch it up and we look at cosine, what we can do to start is kind of a similar concept. We want to think about what does the parent function look like? And when I say parent function, I mean the original cosine. So our original cosine, again, if we think about our original graph, it's going to look something like this. It starts up at 1, and it goes down and up, and it keeps on going forever, right? And if I wanted to, I could keep going this way. But again, I can limit my window to right here, so we have that one-to-one correspondence that we need for it to be a function. Now, if we think about that window, the max is at 0, and your minimum is at pi, which is exactly where this interval of 0 to pi comes from. If we think about our unit circle, that means from 0 to pi, we're going to be looking at quadrants 1 and 2. So again, when we look at the inverse cosine of 1/2, in this case, remember, cosines are connected to our x's. So we can come up here and we want to figure out what x value has an x value of positive 1/2. And if we look up here, that's going to be this point right there has an x value of positive 1/2. So our answer for that is just the radians that correlate pi over 3. Now, again, cosine, or inverse cosine, its domain is going to be negative 1 to positive 1. So let's take a second and just kind of recap that bit. If we look here, our domain of this guy is going to be 0 to pi, and our range goes from negative 1 to positive 1. Okay, but again, our inverse function, our domain and ranges flip. So this is negative 1 to positive 1, and our range is 0 to pi. Okay, so when you look at this, this falls outside of that domain. So therefore, again, this one does not exist. It only goes from negative 1 to positive 1. If we look at number 7, the inverse cosine and the regular cosine, those cancel each other out. Pi over 9, again, is going to fall in this first quadrant. So we can just use it. We don't have to worry about doing anything fancy with it. And our answer is just going to be pi over 9. Number 8, our two things cancel. 5 pi over 6 in this case will fall in that second quadrant, which is now something that we can use. So we can come over here and recognize that those two just cancel each other out. So now you're at 5 pi over 6. Okay. So again, the reason we have to kind of limit that is to be able to say that your inverse function is a function. If it failed the horizontal line test initially, it is no longer a function. So that's why we have to take and use that snippet. Here it's in your first and fourth quadrant for the inverse sine. Here it's in your first and second quadrants. Okay. The last thing that I would consider to be a difficult task to just kind of crush here is your inverse tangent, And again, if we correlate this back to our parent function, okay, if we think about this, your asymptotes are going to be here and here, and it does one of those squiggle deals. And at this point, it would restart, right? And all of a sudden, as we have a restart, it's going to fail that horizontal line test. So now, if we look here, this is the part that we're going to focus on. Okay, so again, if we think about our domain and range, your original domain of just that little window is negative pi over 2 to positive pi over 2. And your original range is negative infinity to positive infinity because it goes up and down forever. Again, if it's inverse, your domain and range flip-flop. So this is going to be negative infinity to positive infinity. Range is going to go from negative pi over 2 to positive pi over 2. And so if you think about that range or that interval that's going to work, that negative pi over 2 to positive pi over 2, we are back in these two quadrants. We're back in those two quadrants, okay? Now keep in mind that up here it's positive and positive, so that means that your tangent is positive. And here this is positive, negative, which means that your tangent in this one would be negative, okay? So when we look at this, root 3, that tells us that we're going to be in quadrant 1, because again, since it's inverse tangent, we're limited to 1 and 4 automatically. Because that is a positive root 3, we're going to be up in that first quadrant. So if we look at our points, here's the deal. We look at those points, none of them are root 3. However, this one has a root 3 in it, okay? So as kind of a recap with your tangent, keep in mind tangent is equal to sine over cosine. And so, or if you want to think of it this way, y over x, right? And so if you think about that point that we just starred, that's why we're looking up there at that one, because your y value is root 3. Here, your x value is root 3. We don't want that one necessarily. But what I would encourage you to do is check it. So our y value is root 3 over 2. Our x value there is 1/2, which is the equivalent to root 3 over 2. Flip that fraction, those cancel, so we get root 3. So that tells us that the point that we had limited it to, the point that we had starred up here, is the winner. Okay, because if we had simplified it and it wasn't going to simplify to be root 3, we know we have to do something else. The radians that correlate with that particular one is pi over 3, and that is our answer. So we have to do a little bit of check with that. We can't just look at the unit circle and pull it straight off like we did with cosine and sine. All right, these guys, this is just punching it in your calculator. Just make sure that your calculator is in radians and not in degrees. So if we do the arc sine of negative 0.81, we get negative 0.944. The next one, 0.738. And the last one, negative 0.245. This is just punching it in your calculator. So guys, I would really encourage you, don't just take my word for it. Make sure that you can type it in, that you can get the same answers for yourselves. All right. So guys, again, basically you are just looking at your unit circle and you're pulling out the radians that correlate with those certain points that it's asking you to focus on. Okay. Only other thing, be mindful of which quadrants you're narrowed to. So for sine, you're in quadrants 1 and 4. Same thing with tangent. The only other one, cosine, you are in quadrants 1 and 2. Guys, ask questions if you have them. They are going to pop up. Don't be shy. Thanks.